Hello everyone. It is a wonderful application of complex numbers. The question when we read the question, we don't smell that it's an application of complex number. And but when we observe the given information, it is easy to solve the question just by an application cube roots of n unity. So the idea of approaching complex numbers from this question is that as it is given that 120 degrees between the two rays, pair of rays. So here the question, first let us understand the question here. Initially there is a man standing at origin, moves one unit towards east, and after that he takes a he takes a turn of 120 degrees in anti-clockwise direction, and he moves 1 by 2 units parallel to this x bar given. This x bar is not x axis, it's a name given to the ray. And then he takes 1 by 4 units parallel to y bar, like this. Again, he continue moving like that, 1 by 8 units, and then 1 by 16 units, and then 1 by 4 units. This will be keep on continuing. It is like a something like a spiral. So he continues to move like that, and the distances every time 1 by 2, 1 by 2 square, 1 by 2 cube, like that. The distance traveled in a particular direction is been uh, in a gp 1 by 2, 1 by 2 square, 1 by 2 cube, like that. Now as t tends to infinity, if t is the time, if t is the time right from the beginning of the origin, after a certain time t, okay, we need to calculate the distance. As t tends to infinity, what would be the estimation? What would be the estimation of that one? Okay, let's try to solve this. Let us start our origin vertex at origin at 0 0, and then the coordinates of the point, let us call this as a. These coordinates would be 1 comma 0, and coming to here, and from this point, look at that. If the angle made by this x bar with a pause east of the direction, east direction, if I assume that this east direction is real axis, then the angle made by this one with 120 degrees, then in this direction, this is the direction parallel to omega. What is omega? Cube root of unity. 1 omega, omega square are cube roots of unity. That is, they are the roots of z cube minus 1 equals 0. And we know that result is related to that 1 plus omega square is 0, and omega cube is 1. So, because that angle, the argument of that cube root of unity is 120 degrees. So, this is in the direction of omega. Then, obviously, this is in the direction of omega bar or omega square. Right. Now, let us start our calculating the distance traveled by the person in this direction. So initially he travels 1 unit, and then he travels a distance of 1 by 2 units in the direction of omega. That means the distance traveled will be 1 by 2. Next, after that, the next direction travels is that he travels it's a distance of 1 by 2 square units in the direction of omega square. So that is omega square by 2 square. And then again in east direction, he moved 2 cube units. So without loss of generality, that one I can be written as omega cube. And then again in the direction of omega, so 2 power 4 units, that you can take it as omega power 4, and so on. and this series goes to infinity. As that they are asking, as t tends to infinity, what is it? So sum of n terms in infinite terms in GP, a by 1 minus r. First term is 1, and the common ratio is omega by 2. So this comes out to be 2 by 2 minus omega. This is the total distance. This is the complex number which represents that the sum of it is the sum of all the distances traveled. The magnitude of this gives you the distance traveled. So modulus of 2 by 2 minus omega, if you calculate it, so it is modulus of 2 by modulus of 2 minus omega. So 2 divided by, it is 2 minus of minus 1 plus root 3 I by 2 omega. So if you simplify that, that's a 2 by, it is a 4 plus 1 minus root 3 I into 2. So it comes to 4 by root over 25 plus 3, that is root 28. So that comes to be 2 by root 7. 2 by root 7 is the value. So it's a wonderful application of this complex numbers, particularly nth roots of unity. When the question related to geometry, it can be applied. So please keep watching our channel, and more such wonderful and useful content of IIT JEE 2025 and 2026 will be uploaded. Hope this will help you. Thank you.